right. We have 3 more examples of everything that you can tell about the graph of a function from its first and second derivative, and what we already know about asymptotes. Ooh, asymptotes in for the key, and intercepts. So number 44. I don't think we've graphed one that had the natural exponential function in it, and 44 does. F of x equals -2 plus e to the 3x times 4 minus 2x. And by the way, Lillian asked me about one of the problems on the homework if we had to find the x-intercept. How bad was it? What did that have in it? Or was that not you?
It was like
Oh, okay.
x minus 2 sine x.
Okay, gotcha. It was a trigonometric function. It would have been really difficult to find the x-intercept. This one's very difficult to find the x-intercept. We're not going to spend time doing that. And I promise you that if there's some transcendental function that's going to be pretty difficult to find the x-intercept, I will either not give you that part of the problem, or I promise it'll be one that it's not so hard to find the x-intercept. All right, what's the domain of the natural exponential function? You can let x be anything. You can raise e to any power. E is just a number, not quite 3. So what's the domain of f of x in number 44? Yeah, you can let x be anything from -infinity to infinity. And then how do you find y-intercepts? You let x be 0, and can you see what that is if you let x be 0? +2, I think, because this would be e to the 0 is 1, 4 minus 2 is, no, I'm sorry, 4 minus 0 is 4, and so all we have is -2 plus 4 is +2. So when x is 0, y is 2. We could attempt the C part, but I think it would be very difficult to find the value of x that makes that expression 0. So just question mark's fine. What about vertical asymptotes? Does the natural exponential function have any vertical asymptotes? No. The primary vertical asymptotes we're watching out for, rational functions have vertical asymptotes at whatever makes the denominator 0, as long as you've expressed the rational function in simplest form. You know, look to see if there were any factors you could cancel out. What else has a vertical asymptote? Some trig functions, actually all the trig functions except for sine and cosine. And then there's one other big one that has vertical asymptotes. No. The natural log function has a vertical asymptote. E to the x has a horizontal asymptote, but no vertical asymptote. So how are we going to find the horizontal asymptotes? All we had for asymptotes was that rule for rational functions, which are quotients of polynomials. Look at the degree of the numerator and degree of the denominator. How else could we find horizontal asymptotes without wrapping it on the calculator? Showing some more. No, what is it that we're finding when we set the function equal to 0? Or are you just talking about part of it, set part of it equal to 0? Is that? Yeah, that wouldn't give us the hard. Hey, what's the definition of horizontal asymptotes? What does that even mean when you say something is a horizontal asymptote? It can possibly go above, but if it does go above, it's got to come back down. The definition of horizontal asymptote is that y value that the graph approaches as x goes either to what? Negative infinity or positive infinity. It's a y value that that y approaches as x goes either forever to the left or forever to the right. So we could actually, and we did in 4.5, look at things such as in the E part here. We could look at the limit as x goes to infinity and the limit as x goes to negative infinity. And if those limits exist, then there's a horizontal asymptote. If those limits do not exist, there's not a horizontal asymptote. So we're looking at the limit as f of x, limit of f of x, as x goes to both positive infinity or negative infinity. What about x getting infinitely big here? What can you tell me about e to the 3x as x gets infinitely big? Yeah, that's getting huge. And then what about the 4 minus 2x as x gets infinitely big? It's getting very, very small. It's 4 minus a bazillion. So we have basically a positive infinity times a negative infinity. Something else I was thinking, what was it? That adding -2 at the end is not going to make much difference. I'm not sure why. We'd have a positive bazillion and a negative times a negative bazillion. What's the limit as x goes to infinity? Negative infinity. Your graph has no lower limit. As x goes to infinity, your y is going to keep getting increasingly negative. What about as x goes to negative infinity? You know what? Let me just write the function here so we can put in a middle step instead of just saying limit of f of x. Let me write the function and actually put negative infinity in place of x so we can look at it. -2 plus e to the 3x times 4 minus 2x. All right. If x is going to negative infinity, then the not technically correct notation of that -2 plus still wouldn't make any difference. So let's just look at the e to the negative infinity times 4 minus 2 to the negative infinity. What does e to the negative infinity go to? Yeah, because that's 1 over e to the infinity. That's 1 over a bazillion. And that's getting closer and closer to 0. What about what's inside parentheses? Yeah, it's getting bigger and bigger and bigger. You know what? I said something wrong. That -2 is going to matter because this part's going to 0. This is -2 plus 0 for -2. Which, Lillian, that's what you said to begin with, right? Your gut just kind of whispered -2. Your gut's pretty good. Yeah, that's like 0 times a bazillion. Is 0, and then 0 plus -2 is -2. You didn't get that one. All right, so the horizontal asymptote, if you write it as an equation, not just a number, is what? Y equals -2. And the only slant asymptotes we have talked about occur when rational functions, what specifically about a rational function tells you there's going to be a slant asymptote? 1 degree, the numerator is 1 degree higher than the denominator. So that doesn't apply here. Now I gave you the work for the first derivative and the second derivative out to the side. They weren't the most terrible first and second derivatives I've ever taken. But I went ahead and transferred the derivatives over here. F of x is -2 e to the 3x times 3x minus 5. What are the critical values of the first derivative? Definitely. Anything else? I don't know. Does 0 make the derivative undefined? No, I can let the derivative be 0. I can let, I can let x be 0 in the derivative. I can let it be positives and negatives. I'm not just looking for what makes it undefined. I'm looking for what makes it 0 also. There's nothing that makes it undefined, but 5/3 makes the derivative equal 0. So it's our only critical value of the first derivative. What about the second derivative? Is there anything that makes it undefined? Well, it doesn't make it undefined, though. It makes it 0. Nothing makes it undefined, and the only thing that makes it 0 is 4/3. So I went ahead and I made my sign chart with the critical numbers of the first and second derivative on that number line. You want to, you can go ahead and say the function goes from -infinity to infinity with no discontinuities. There was nothing that made the original function undefined, so there are no discontinuities. And then I use test points to find the sign of the first derivative and the sign of the second derivative. Look at that and tell me where that function has increasing intervals. -infinity to 5/3, and you can list that as a single interval because there's no discontinuity at 4/3. And where are the decreasing intervals? All right, 5/3 to infinity. You're looking for where the first derivative is negative. How do you spot relative extrema by looking at the sign chart? Where the function changes, increasing to decreasing or decreasing to increasing. And it looks like that happens at 5/3. Is there a max or a min at 5/3? The function's going from increasing to decreasing. So there's a max at 5/3. And I went ahead and calculated a y value. If I had the exact value, then the y value would have an e in it. I just calculated a decimal approximation because I want to graph that. Pretty close to 97. I'll do my best on the test. Remember to be clear and tell you whether I want exact answers or decimal approximations. If I'm not clear about that, then you use the best judgment and I'll have to take it. Yes, we're looking for points on the original function, not points on the derivative. What about relative minima? There's nowhere the function goes from decreasing to increasing. So there are no relative minima. What do we look at to determine concavity and points of inflection? Sign of the second derivative. So where the second derivative is positive, the function's concave up. What's my concave up interval? -infinity to 4/3. And concave down, second derivative is negative from 4/3 to infinity. How do you find the point of inflection? What's the definition of the point of inflection? That's exactly right. So that happened at 4/3. So the point of inflection is 4/3, and whatever you get when you plug 4/3 back into the original function. I already did and got a little tiny bit over 70. So let's put it on the graph. Looks like I probably had to play with my on-screen graphing calculator a while to figure out what to count by, my X's and Y's. It looks like I counted by 0.3s on my X's.
I think it's thirty.
Yep. It is a third. And my Y's I counted by 20s. So which parts have points or lines that we can graph? B does. E's a horizontal asymptote. N is a relative max, and R is a point of inflection. So let's graph those things first. 0, 2 is the y-intercept. You're counting by 20. That's going to be darn close to the x-axis. Horizontal asymptote is -2. That's also going to be darn close to the x-axis. The relative max is 2 2/3, or 2.3, and y is almost 100. Wait, that's 3 goes in the pipe. 1 2/3. So 1.7 and almost 100. And then 4/3 is about 1.3 and a tiny bit over 7. So is that what your points look like? Y-intercept. Point of inflection, and then your x-intercept. All right, let's graph it. What do we know is going on with this graph as x goes forever to the left? What's going on with the graph? It's approaching -2, that horizontal asymptote. So I'm going to make the graph look like it's approaching. And let's see, -infinity, it was from -infinity to 4/3, it was increasing and concave up. So make that part of the graph look increasing and concave up. All the way to 4/3. And then what can you tell from your sign chart about 4/3 to 5/3? Increasing and concave down. That's what increasing and concave down looks like. And sure enough, it looks like the concavity changes at 4/3. And then what's going on with the graph from 5/3 to infinity? Decreasing, concave down. How far down? Does it just go down to the -2? And we needed to know that. We needed to know that as x goes forever to the right, my y's get infinitely small. So it turns out that this only had a horizontal asymptote in one direction as x goes to -infinity. If you graph that on the calculator, that's pretty darn close. All right. Number 46. Another function with the, I think all three of these may have the natural exponential. No, 48 has a logarithmic expression in it. So 46, 8/2 plus 3 e to the negative x over 2, what's the domain of that function? Can you let x get infinitely big? Yeah, can you let x get infinitely small? Can you let x be 0? Yeah, the exponential function, the domain is negative infinity to infinity. And the only way this domain could be, excuse me, only way that denominator could be 0 is, let me write it out here in case anybody needs it. If I set 2 plus 3 e to the negative x over 2, if I set the denominator equal to 0, I'd get that exponential expression would have to be negative 2 divided by 3. And is there e to any power that gives you a negative? No. You have a positive base. There's no power of positive base that gives you a negative. So the domain is negative infinity to infinity. You can let x be anything. What about the y-intercept? You let x be 0, you'd have e to the 0, e to the 0 is 1. And so that denominator is just 2 plus 3 times 1 or 5. The y-intercept, when you let x be 0, you get y is 8/5. What about the x-intercept? Tell me whether you think it is hard to find, easy to find, or not, or couldn't possibly be one. I'll give you a hint. I would feel comfortable giving you or asking you on the test for the x-intercepts here. It's either easy to find or non-existent. How do you find the x-intercept? Wait, how do you find x-intercept? Setting f of x or the whole thing equal to 0. That function's a fraction, and the only thing that makes a fraction 0 is what? If the numerator 0, is there any value of x that's going to make that numerator 0? No. So there is no x-intercept. It's not that it's hard to find, it's there isn't one. What about vertical asymptotes? Since that's a fraction, it is possible that we have a vertical asymptote. Do we? Because we already said there's nothing that makes that denominator equal 0. So that was really the word for A and B. There's nothing that makes the denominator 0, then there's no vertical asymptote. Possibly a horizontal asymptote, because we know that about e to the x. How do I find or even think about a horizontal asymptote? As definition of horizontal asymptote is a limit as x goes to infinity or negative infinity. So let's see, if we let, this is part E, if we find the limit as x goes to infinity of 8/2 plus 3 e to the negative x over 2. As x gets infinitely big, does that limit exist? Can you tell what it would become?
Because we do X. Then no.
Oh, but it's e to the negative x. Let's do that. Ooh, I'm glad you said that, Neil. No, because that would be moving part of a term upstairs. I can't just bring the e to the negative x over 2 to the numerator to make the exponent positive. Can't do that unless you can factor out e to the negative. And we can't factor out an e to the negative, but we can write this as 3 over e to the positive infinity over 2. Because we're putting in a positive infinity, and then we're bringing the e to the x over 2 to the denominator. So what's that? E to the, it doesn't matter if you half infinity or not, it's still getting infinitely huge. So what's 3 over e to the infinity? 0. 3 divided by a bazillion. Each person gets a crumb. That second term of the denominator is just 0. And so what's left of that expression? Yeah, 8 over 2 plus 0. So there is a horizontal asymptote as x goes to positive infinity, y is going to 4. Some graphs have 2 horizontal asymptotes. So we better check the limit as x goes to negative infinity. Let's see. If x is going to negative infinity, what is e to the next negative x over 2 going to? Yeah. A negative times a negative would make that exponent positive, and e to a positive infinity is infinity. So this is 8 over 2 plus infinity. Yeah. 8 divided by 2 bazillion and 2 is 0. So we do have 2 horizontal asymptotes. One is y equals 0 and one is y equals 4. And we're not going to have a slant asymptote. And I don't know what happened to my underlines there. All right. The first derivative, I gave you that out to the side. Was probably a good bit of work to find that. Did I give it to you? Yes. Okay. So the first derivative is 12 e to the x over 2 divided by 2 e to the x over 2 plus 3 squared. Oh, dang it. How did my lettering get off? Because I didn't leave a blank. Oh, that's what was wrong. That double blank there was supposed to be 1 for the first derivative and 1 for its critical numbers. Okay, don't worry about it. For the G part, are there any critical numbers of the first derivative? Is there anything that makes it undefined? Nothing makes that denominator 0. Is there anything that makes it 0? No. So there are no critical values for the first derivative. What does that tell you about anything else? If you don't have critical values, what is that? We are. It's oh, what's that word for? Oh, monotonic. It's monotonic. It doesn't change from increasing to decreasing. either always increasing or always decreasing. What is that? That's one other important thing that tells you.
There's no,
No, that comes from the second derivative. There's no relative extrema if there are no critical numbers. So, I'm gonna go ahead for the m and the n parts and put none. Because this function's either always increasing or always decreasing. What about critical values of the second derivative? I gave you the second derivative. Is there anything that makes it undefined? No. Is there anything that makes it 0? What about what makes 3 minus 2 e to the x over 2? Could there possibly be anything that makes that equal 0? I know there's not anything that makes e to the x over 2 be 0, but what about that second factor? If you got the natural exponential function by itself on the left-hand side, what would you have on the right? And it'd be a positive 3/2, wouldn't it? Is it possible that there's some power of e that gives you 3/2? Yeah. How can I find that value? You could take the natural log of both sides. And what would the left-hand side become? Natural log of e to the ugly, undo each other and just leave you the ugly,
and that's all.
and then multiply both sides by 2. I'm going to just write that as 2 natural log of 1.5. So there is a critical number for the second derivative. And I believe I punched that on the calculator. Somebody double check this, but I got 0.81-ish. Okay. That's why I have my 0.81 on the number line. Again, I'll tell you if I want an exact value. If I don't say give exact values, you can assume decimal approximation's okay. All right, sign chart. That function, we said its domain was -infinity to infinity. There are no critical numbers of the first derivative. There's only a critical number for the second derivative. So we only need 2 test points. Your favorite number less than 0.81? Yeah, try to make this easy. Let x be 0 in the first derivative. Here is the first derivative. Can you see what x would be if, or what that would be if x were 0? Not what I was thinking. E to the x over 2 would be 1. So 12 times 1 is 12. Denominator 2 plus 3 is 5. 5 squared is 25. So 12/25. And really, you know what? We didn't even have to do all that because all we care about is the sign of the first derivative. What can you tell me about that denominator? And what can you tell me about the numerator? It's always positive. So the first derivative is always positive. There's nothing that makes it negative. That's why there were no critical numbers. So positive to the left of 0.81, positive to the right of 0.81. What about the second derivative? Right here, if we plugged in a 0, what would the sign of the numerator be? That'd be 6 times 3 minus 2, and 3 minus 2 is positive. What about the denominator? Positive, and a positive divided by a positive is positive. What about your favorite number to the right of 0.81? 1. I put a 1 into the first derivative, am I gonna get a positive or a negative? Or second derivative? Or 1 in the second derivative? You might have to punch on the calculator 3 minus 2 times e to the 1/2. But I believe it'll be negative. Yeah. So where is this function increasing? With any skips, hops, or jumps in the middle? No, just negative infinity to infinity. Strictly monotonic. What about decreasing intervals? There are none. What about concave up? Negative infinity to 0.81, wherever the second derivative is positive, and concave down from 0.81 to infinity. So what's a decimal approximation of my point of inflection? 0.81. Actually, if you use the exact value, if you let x be 2 natural log of 1.5, that turns out to be a nice, pretty, just 2. But if you use 0.81, that's close enough. All right, how many points and lines do we have? B gives us a point. E gives us 2 horizontal asymptotes. Q gives us a point of inflection. And that's all. My y-intercept is 0 and 1.6. My horizontal asymptotes are 0 and 4. Yes, because I messed up my numbering right there. I'll fix it. Or next fall. 0 and 4 are my horizontal asymptotes. And 0.812 is my point of inflection. So what can you tell me about the behavior of this graph from negative infinity to 0.81? Increasing in concave up. And you can also tell me that as the graph goes forever to the left, what is my y approaching? Yeah, I figured that out in the E part. Forever to the left, the graph is approaching 0, and then all the way to 0.81, it is increasing in concave up. That. And then from, yes, ma'am. That's what I was just thinking, because I was about to have trouble with making the next part work. What did I say? 0 and y is 8/5, and then 0.81 is not over here. 0.812. Ah, that makes more sense. Again, you can make a mistake. Just find it. Up to 0.81, this function was increasing and concave up. And then 0.81 to infinity. What can you tell me about the graph? Right, it's still increasing, but now concave down, with that 0.81 being an inflection point. Kind of looks like arc tangent. I mean, it's that shape or cube root of x. All right, any questions? All right, let's do one more. And I don't believe we've done one with a natural log in it. So number 48. F of x equals 1/24 x cubed minus natural log of x. Yes, what about the domain? Can't be negative or zero, because I can't take the natural log of zero. So how would you write that domain in interval notation? 0 to infinity, not including 0. How do you find a y-intercept? Let x be 0, and what can you tell me about that? You can't let x be 0, so there is no y-intercept. What about x-intercept? Set y equal to 0, squint really hard. I think I did that, and it was pretty hard to solve that equation. And that's the kind of like the one that you asked me about, maybe with a sign in it. I can't factor an x out there, so I just have don't know, won't ask on x-intercept. What about vertical asymptote? We know natural log has a vertical asymptote at 0. That's not just a discontinuity. That's as far as I can go to the left. Actually can't go to 0. So the vertical asymptote would be x equals 0. The natural log functions have horizontal asymptotes. No. Natural exponential functions have horizontal asymptotes. What about slant asymptotes? No, no slant asymptote. I love how differentiating a logarithmic function often just gives you an algebraic function. Do I have to work to that out to the side? No? Okay.
But it's not.
I have no idea. Well, let's do it real quickly. Yeah, let's just do it real quickly. That's what I was going to say, is this one wouldn't be hard to differentiate. And I don't know how y'all ended up printing different things. That's weird. I don't know. But f prime of x, the derivative of 1/24 x cubed would be what? (1/8) x squared. And the derivative of natural log of x, 1/x. Before I can find critical numbers, I'm probably going to need that to be combined as a single fraction. So I can multiply the second term by x over x and get, let me do it this way. Multiply the second term. The LCD would be 8x, so I'd need to multiply this one by 8/8, and this one by an x over x to get my common denominator, 8x. X cubed minus 8/8x. That numerator is a difference of 2 squares. Been a long time since we factored that's not difference of 2 squares, difference of 2 cubes. Been a long time since I factored a difference of 2 cubes, but it does factor into a binomial factor times a trinomial factor. Little parentheses, big parentheses. So what are the critical values of the first derivative? Is there anything that makes it undefined? 0 cannot be a critical value? Is it a critical value of the first? Because the function's not defined there. That's where you have a vertical asymptote. So 0 is not a critical number. Are there any other critical numbers? Or are there any critical numbers of the first derivative? 2 would make the numerator 0. I happen to know when I'm factoring the difference of 2 cubes, that trinomial factor only has imaginary solutions. If you set it equal to 0, use quadratic formula, you'd see that. But the critical number is only x equals 2. The second derivative, you could either use this first derivative as a single fraction and use the quotient rule, or it might be easier to use that 1/8 x squared minus x to the negative 1 that I had before I combined them. So the second derivative would be what? One-fourth x minus 1/x squared. Common denominator would be 4x squared. So you multiply the first one by x over x and the second one by 4/4. Yes, 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 thank you. That would be plus, because a negative times negative is positive. Yeah. That's a single fraction. You would have x squared plus, no, x. I need to multiply that by x squared over x squared. So x cubed plus 4 over 4x squared. All right. The only value that makes that undefined is 0, and 0 can't be a critical number. What about what makes the numerator 0? Is there anything that makes the numerator 0? I can take the cube root of a negative. I can't take an even root of a negative. So in part J, when I set x cubed plus 4 equals 0, x would be, do I have a plus or minus here? No, that's when I take even roots of both sides. This is just x equals the cube root of negative 4. And I can get a decimal approximation of that. Why do I not really need this? Why can I tell right off the bat that's not a critical value? It's not even in the domain. I can take the cube root of a negative 4, but I can't let x be a negative number in the original function. So not in the domain of f of x. So what does that tell us about critical numbers of the second derivative? There are none. Which tells us what else? No inflection points. And what does it tell us about concavity? No change in concavity. It's either always concave up or always concave down. All right. So what do we need to put on our sign chart? 2 is our only critical value. I might want to put something that looks like a vertical asymptote at 0, because I can't let x go to the left of 0 at all. But I can let x get infinitely big. So I put 0 to infinity on my sign chart. All right, first derivative for numbers between 0 and 2. Here's the first derivative. If I let x be 1, do I get a positive or negative? Negative. And if I let x be bigger than 2, I get a positive. So there's where increasing and decreasing change. What about second derivative? Here's the second derivative. If I let x be 1, I'd get a positive. If I let x be 3, I'd get a positive. So what are my increasing intervals? Wherever the first derivative is positive. Decreasing intervals. 0 to 2, can't include 0, won't include 2. What about relative maximum? What am I looking for on the sign chart? Where the first derivative changes from positive to negative, and there isn't any place on the sign chart where the first derivative changes from positive to negative. What about relative minimum? There is a point where the function goes from decreasing to increasing, and that's 2. I just got a decimal approximation for that y value. Where did I plug the 2 to get that negative 0.36? Original function. All right, where is this function concave up? But I don't want to go negative infinity to infinity. 0 to infinity. And concave down? Nowhere, 9. What about point of inflection? If there's nowhere the graph changes concavity, then there's no point of inflection. So what do we have? We can points and lines. I have a vertical asymptote. There may be an x-intercept, but we didn't find it. And I have a relative mean. That's the only 2 things I can graph to begin with. Vertical asymptote is the x-axis, which I started to draw horizontal. Vertical asymptote is the y-axis. And the point 2, negative 0.36. All right, what do we know about the graph from that vertical asymptote up to the 2? Decreasing and concave up. Decreasing and concave up from the vertical asymptote to that point. And from that point forever to the right, what can you tell me about the graph? Oh. So there definitely has to be an x-intercept. Actually, there has to be 2 x-intercepts to get to that 2 negative 0.36, but it's just hard to find them without graphing it. All right. Any questions? Let me make sure you know what you need to do. Here's the last 4 problems you have. And then hopefully this weekend you worked on that practice test. We have 2 days. I actually have one more new kind of problem. It's just the way the questions asked to show you tomorrow, and then tomorrow and Wednesday. Anything you need to ask from the practice test, which contains 17 problems that you have the answer to, for the chapter 3, chapter 4 review, which I gave you the answers to. Y'all have a good rest of the day.